All right, so our next speaker is Ted Drake. And Ted Drake is an experienced front-end engineer, developer, evangelist, and accessibility expert. Ted leads the accessibility efforts for Intuit's desktop, web, and mobile products. And previously, Ted worked on some of the most viewed websites on the Yahoo network and participated in the development of many products, platforms, and applications. He worked with products to improve mobile accessibility, both HTML5 and iOS within Yahoo's Accessibility Lab. You can follow Ted at Ted_Drake on Twitter. And Ted, I'm going to go ahead and turn it over to you and mute myself. Take it away. Sorry, Ted, I had you muted there. Go ahead.
I don't know if when I'm talking or not, so let me know.
You're doing good.
Okay, sounds good. Thank you everybody for coming in and logging in, and I want to thank the Paciello group for asking me to participate. Wearable computing, and accessibility is something I've been interested in for a while, but I haven't really delved into it until fairly recently. So most of what I'm going to be talking about is more in theory and in research. I don't necessarily have a lot of prototypes or anything to show you, any code or anything like that. So what I'm hoping to do is introduce the concept of what is a wearable computer, and what can you expect and how can you work with other groups in order to build it. One thing I did want to mention real quick, I have a website called wearability.org. It's just basically a blog that I'm using to keep information that I find about this concept. This presentation I have already converted to an HTML version where you'll have links to all of the projects mentioned, plus videos and some of the images. So you'll be able to look up that information by going to wearability.org. Also, this presentation is on slideshare.net/7mary4. So wearable computers essentially is the concept of taking the computer. Well, first we went from our computers to our mobile devices. We've gotten really used to holding a phone, talking into a phone, and we've become very used to working with applications on our phone. And phones have been great at being able to provide us all sorts of sensors, from gyroscopes to compasses, movements, accelerometers. We know where a person is, we know what time of day it is, and we know who the person is. We've got a lot of information that we've gotten from our phones. And we've been able to take that information and build some really nice applications. The next logical step is to say, what if we don't just look at our phone, but what if we look at what our fingers are doing, what our eyes are doing, what our ears are doing, what our toes are doing? What we start looking at what's inside of our body, or what we're wearing on top of our body. Moving our sensors outside of the phone and basically dispersing them on the person. This is where we're going to with wearable computers. And that's what I want to start talking about tonight. And then once we understand what a wearable computer is, how can we use it to make assistive technology even better? I want to talk a little bit about the history. Because a lot of people assume that wearable computers were not even considered until Google Glass came out. That was the first wearable computer that I think most people understood. So what I want to do is go back and look at some of the progression. For instance, this is really kind of pushing it, but in World War II, there were a lot of people that had facial damage during the war. So there were these masks that were made that were worn over the face. It's like a prosthetic, but it's more of a mask. I was looking for old versions of assistive technology that were worn, and you're essentially in the old days, you're going to be looking at prosthetics, mobility devices, and glasses, eyeglasses. when you go way, way back in assistive technology. But let's push forward just a wee bit, and you'll see that electronic, technical, wearable computers have advanced significantly in the last 10 years. What you see on the screen on the left is a person wearing a backpack, and on either side of her head is a camera and a display unit. And what this thing is able to do is detect obstacles. And it shows the person the view, and it shows you when the obstacle is coming together. This is, as you can see, pretty clumsy. There's a backpack inside, there's a computer inside the backpack. They're dealing with fiber optics, infrared light. A lot of stuff went together to get this thing working. Let me show you a demo of how this works. And there's no sound. It's just letting the user know when they see an object. So that was in 2004. Now, I don't know when this was made. This is the eyeglasses. I first saw it at the CSUN conference, I think about 3 years ago. It looks like a plastic pair of black sunglasses. When you put them on your head and you move something close to your head, it detects that there's an object. And when it detects that object, it vibrates. So if someone had limited to no vision and they were walking down the street, the cane or the guide dog can tell you that, there's a step. They can tell you that there's something low, but they don't necessarily tell you that there's a branch that's hanging low. And so this eyeglasses, what it does is it quickly tells you that you better duck before you hit something. So we've already seen it go from backpack with all this technology to something, normal size, still a little bit clunky and simplistic. It doesn't have a virtual reality display, but it's already simplified the process. And then we go to what everybody is looking at right now, which is Google Glass. Google Glass has taken all of that equipment from 2004 and essentially miniaturized it into something that fits on the side of an eyeglass frame. Google actually has a patent on obstacle detection. I believe the patent was filed or granted about 4 years ago, 3 or 4 years ago. So who knows how that's going to be integrated into Google as a platform, Google Glass as a platform. I'm sure there are probably a lot of other people that are working on how they can adapt Google Glass. And the other thing I want to mention when I talk about Google Glass is I think of Google Glass as just the first of iframe-based computers. Think about them as like BlackBerry. BlackBerry was the phone. Google Glass is the camera-based eye assistive technology thingy. But in a year from now, we may be looking at Google Glass saying, oh yeah, that thing. When I talk about Google Glass, I'm really thinking about wearable computers that sit on the face, around the eye. Think of it as like Kleenex or Frisbee at this point. So one of the things that's really helped us with wearable computers and assistive technology also is acceptance and ubiquity. It used to be when a kid had assistive technology, that technology stood out from the classroom. They were the unique person that had strange equipment that did weird things and had strange sounds. And kids were either afraid of them or they were curious about them. But that's no longer happening. I'm showing a picture of about 7 little kids sitting at a table, and each one has an iPad. In this picture, you really have no idea which kid, if any of them, is using that iPad as assistive technology. So what we're seeing now is that everybody's getting used to seeing phones, watches, eyeglass. Definitely we're used to seeing things that sit on your ear like a Bluetooth headphone. We're used to seeing earrings, finger rings. We're used to seeing piercings and jewelry all over the body. So seeing something that's taken out of the phone and put on the body, we're getting kind of used to that. It's not going to be too surprising. So we don't have to worry about stigmas. We don't have to worry about causing problems, for the most part. And we don't have to learn things over again. Another thing I think is really, really important was something that came up when the iPod was developed. And I have a quote from Steve Jobs. He said, "What made the Rio and other devices so brain dead was that they were complicated. They had to do things like make playlists because they weren't integrated with the jukebox software on your computer. So by owning the iTunes software and the iPod device, that allowed us to make the computer and the device work together, and it allowed us to put the complexity in the right place." So I don't know about everybody else in the room, but I do remember having a Rio. I did have an MP3 player before the iPod, and it was slow. And I do remember it being clunky and hard to figure out. But what the iPod did is they basically said, I'm going to create a device, and that device is going to be really good at playing music. And it'll be really good at browsing music. But if you want to import music and you want to create playlists and you want to do a bunch of other stuff, you're going to have to go to the main computer in order to do that. So the device becomes basically a simplified input-output. And the computer becomes the main way of organizing, creating, developing, doing the heavy logic. And that's what we're going to see a lot of with wearable technology. I'm not going to create something that sits on my finger that has to do heavy lifting. I'm going to create something on my finger that is simply receiving inputs and it's outputting a simplified signal to another device. Thinking about wearable technology as intelligent sensors that are dispersed, with the exception of something like Google Glass or some of the others where they actually do have pretty complex devices and processors. Now, the next picture, if you thought the first one was kind of scary, wait until you see this next one. This is a Pacific lamprey. It's a fish that swims around until it finds a host, and then it grabs a hold of them, bites into them, and then starts sucking the blood and everything off. It's really not very attractive. And you might be wondering why I have that on there. It goes back to the Internet of Things. The Internet of Things is this concept that we had where we were running out of IP addresses. Everybody had a website. Everybody had a this or that was connected to the Internet. We quickly ran out of unique IP addresses. So there was this project put on. It was called the IPv6, and it was basically a way of creating IP addresses that we could create so many IP addresses that in theory we really would never run out of them. So now what that means is that every object, everything you do could actually have its own IP address. There's a research group that have looked at this lamprey, and they've created these little nano robots, very small robots that they can actually inject into your body. And these little nano robots can swim through your body and then attach itself to a part of an organ or damaged tissue or something. And they can use these lamprey-like robots to actually do medicine or cut out something, or they can use it to send sensor information back. So imagine that you've got 500 of these little tiny robots dispersed across your body. And each one of those can be contacted separately. And each one of those can send information back. What we're dealing with is the ability to have this huge web of information around your body. I know it's kind of scary, but think about if you had a computer that could actually use that information, what you could learn about your health. Think about the healthcare procedures that would be possible. We'd be able to know when people are going into diabetic shock long before they knew. We'd be able to detect seizures or possibly work with people that have bipolar disorder. You never know. But that's one of the things that's going to be coming up. So as I mentioned, we're looking at computers as being the main source of information, doing the main logic. And what our wearable computers are going to be are intelligent sensors. Not always, but that's what we're going to be looking at primarily is intelligent sensors. It's a lot cheaper for us to build something, make it miniature, cheap, and easy to work with if it's not trying to do everything in the world. So let's look at some of the different sensors. Obviously, one of the first ones that we're going to be dealing with is vision. We're used to vision. Vision is glasses were one of the first things that people built to as assistive technology outside of mobility like crutches and prosthetics. So we've been putting things on our face, and we're used to seeing through glasses, and we're used to looking at glasses. MIT's Media Lab in Boston have been doing a lot of work on eyeglass-based computer. Google Glass was actually born out of MIT's Media Lab. The people that worked on prototypes were in MIT, and then they moved on to Google. But they're doing all sorts of things. They're looking at virtual reality. They're looking at augmented reality. They're looking at eye tracking. You name it, MIT has probably started working on it. This particular picture came from it was an article on MIT's camera culture, which is part of their Department of Media. But if vision is one of our main things that we're used to, sort of like the Power App, the thing that's going to make it move across all communities is hands-free. Everybody wants hands-free technology. Everybody just didn't realize they wanted hands-free technology until Siri came around. The ability to drive down the street and tell your phone that you want to make a tweet and send a tweet out or send a message or read your email or find the news or get directions. You're walking down the street and you have your hands full. These are things that people didn't realize that they could do, actually compute until Siri came around, until some of the other mass culture voice recognition was available. And Dragon worked great, but most people thought of Dragon as that thing I use when I break my arm skiing. And as soon as their arm heals, they put it away. So what we're going to see is that hands-free is going to be built into almost everything we do as assistive technology, unless wearable computers and assistive technology. Unless, of course, you're dealing with something that actually sits on your hand. So I found this project that was being built. The problem with Google Glass is you can talk to Google Glass. You can say, okay, Glass, take a picture. Or, okay, Glass, look up this or that. But at some point, you have to reach up and touch the glass. So it's never completely hands-free. So this is a project which allows you to control your Google Glass by moving your head. So now somebody that's a paraplegic, someone that has absolutely no hand movements, can use Google Glass, and they can do whatever they need with it. Now, if there's anybody online that's watching this and they don't have, I don't have captions for any of my films, mainly because a lot of them didn't have captions when they were put online. A couple of them did, but because of the way I'm doing this presentation, I was not able to save the captions. However, if you go to the website wearability.org and you go through the links, you'll be able to watch all of these videos, and if they have captions, those captions will be available. So let me show you what this video is like, and hopefully the sound will come through.
I'm Mike DiGiovanni. I'm an emerging technology lead at Isobar. I've been working on Google Glass apps. The latest one is called Tilt Control. Tilt Control is a way for people to interact with Glass in ways that weren't previously possible. You always had to resort to using your hands once you got out of a small range of voice controls. With Tilt Control, you're able to tilt your head, use swing gestures and nods to fully navigate Glass and interact with every application and every piece of data that comes across your way. Tilt Control will be useful for people who don't have full mobility in their arms. If they previously used Google Glass, they were greatly limited in functionality. They could interact with the OK Glass menu, maybe tell us to take a picture, record a video. They couldn't do much outside of that. OK Glass, Google, find me a pizza place nearby. So normally when you get the results for a restaurant search, you have to resort to probably a half dozen swipes to be able to actually bring up navigation directions and get to that location. With tilt control, you just tilt your head a few times and make a few winks, and you'll get directions there without ever having to bring your hands up to the side of your head. So now that we have directions up, we can tilt over to the first pizza restaurant, wink to select it, tilt over 3 times, and wink one more time to bring up navigation directions. Now, if you tilt your head in extreme directions, it'll swipe over 2 to 3 times rather than just 1 time. Sometimes that's easier, sometimes it might be easier just to tilt your head 3 subtle times. So the navigation directions are up and going, and we're off. So get some pizza. So to me, the more interesting one is being able to change the volume. It's not cool in any way, but like, hey, you're on the subway or something and you can't hear anything and you're also jam-packed and can't lift your hand up. So you can tilt your head to the extreme left and you'll slide almost all the way over to settings. And you might just need to give one little extra tilt to go into settings. And a wink to select it. And then say if you want to change the volume, just give a long tilt to the right side and you'll be right at the volume. And now able to change it with a wink and another tilt.
There was one thing that he mentioned that I think we need to remember is that he said, what if you were in a subway and your hands were full and you couldn't touch your glasses? So once again, it's going from the idea that all of this assistive technology is not just for people that have disabilities, but as a mainstream functionality. One of the other great things about this is that the code that they created to make this work is available on GitHub. So a lot of these groups that are doing this research, they're making the code available so anybody can implement them on their applications. So one of the problems you hear about glass, and you've heard of people called glass holes, is that you're looking at someone and that someone's got a pair of glasses on their face. And you're talking to them, but people are wondering, what is that person actually looking at? Are they looking at me or are they looking at something in the screen? Do I have their attention? And that's because glasses are front and center. So what happens if you take that same technology and you move it away from the face and you put it on the ear? When you put it on the ear, people aren't going to think twice about it because we're used to seeing people with Bluetooth headphones. And when you put it on the ear, it still has the same benefits of Google Glass. It still is going to track. So when you move your face and you look at something, it's also going to move with you. The other thing that's nice about the ear is that the ear has really good biometrics. So you can tell if someone's heartbeat, you can tell their body temperature, you can tell what their movement is, the speed. A lot of things you can do with glass, you can do with your ear. The other really great thing about the ear, it's hands-free and it's display-free. There's no vision component at all. So the people that are designing for an ear-based one are also thinking about how do you create a user interface where there's no visual or tactile interface. It's all through your ear. This is a Japanese group that created this one, but there's another one that I'm going to show you. This is called Dash, and Dash was created for athletes. Athletes who also want to use the earplugs as earphones, so they also have noise reduction. What's interesting about this is all of the information they're able to get from those headphones. Think about what it can do for someone with a disability or someone with health problems that we need to track. This video is a little heavy on the sexy side, but you'll still get a lot of information.
Come on, faster, go, go, go! Woo!
Heart rate 170, speed 64 kilometers per hour, drop rate 367 meters. Pulse code 92, pace 4 minutes 26 seconds per kilometer.
For those that weren't able to see the video, one of the things to think about is that it was showing people bicycling, skiing, jumping off of cliffs, definitely not able to use their hands, but they were able to go through all those activities, and those earbuds were giving them feedback on how fast they were doing. Like when they jumped off the cliff skiing, it even told them their drop rate, how fast they were descending. These are some of the things to think about. If I were blind and I was walking through San Francisco or something like that, to be able to get that kind of information seamlessly, hands-free, to be able to talk to it and have it do what you need it to do. So what was great about that last one, Dash, is that they were doing a lot of biometrics. Those biometrics were really aimed at athletes. How can I go stronger, faster, longer? We also have biometric groups that are looking at how we can protect people that have epilepsy or diabetic shock or things like that. Dialogue is a company that has created a patch, and that patch detects movements, very specific movements, seizure-like movements. When that patch or that watch detects those very specific movements, it sends a note to the phone. The phone then provides the interface where they can track all of their movements, all of the possible seizures, pre-seizures, and it can also help them contact the emergency very quickly. And then we have clothing, cloth, cotton, or whatever. We can loom, we can weave that with electronic wire, threading that can pick up signals. So we were looking at something on my wrist, or something on my ear, or something on my finger. But when you're wearing a shirt, and that entire shirt is your sensor, it knows when you're twisting, when you're bending, when you're lifting your arm, when you're lifting two arms. All of that entire net of sensors are giving you information on movement, on gestures, on your biofeedback, your temperature, your heart rate, potentially things like if you're sweating a lot, they might be able to detect what's in the sweat. You never know. There is a group called omsignal.com that already have a set of shirts made for men right now. They're working on a line for women. And then we have prosthetics. Prosthetics started out as basically extensions of the body, but now they contain sensors and processors, controllers. There's no reason why you can't put anything you want into a prosthetic limb other than possibly weight concerns. DICA is the group that created the Segway. They just had they've been working on a very, very intelligent arm with huge amounts of movement and control, and that was just approved by the FDA this year, or this week, I should say. I just saw a press release on that. So we are going to see prosthetic limbs that have extreme motor control. We'll have limbs that are controlled by your head, limbs that can detect when you're moving parts of your arm that would have normally reached your finger, would have triggered movement of your finger. They can now really detect those minute muscle movements. I also want to show this concept by a professor out of, I believe, Sweden, Lars Asplund. He started looking at how can we have a keyboard where there's no keyboard? How can we use our hands to do all sorts of gestures? This would be really good for a lot of people that maybe have carpal tunnel, or maybe they have limited movement of their hands, or just for people that want to be able to work at any time. So let me show you this video of his virtual keyboard.
My name is Lars Asplund. I'm a professor in computer science here at Mälardalen University in Sweden. I have a background as a physicist, and I took my PhD at Uppsala University with my professor Kai Siegbahn, Nobel laureate in physics. The virtual keyboard is a device that can be used for wearable computing, or it can be used for iPads, iPhones, or any computer. You have it on your hands, and this is a preliminary version, and the new version will probably look completely different from this one. And in here you have sensors, so you can actually measure individual fingers where they are. You can measure the hand position, where they are in air or compared to the surface. You know which finger is moving down to the keyboard. Your keyboard is not actually visible, but you can have them visible if you have Google Glasses or Oculus Rift. Then you can project the keyboard in your glasses. You have a 2D mouse, you have a 3D mouse, or you can have a multitude of operations at the same time. And now we're talking about the gesture device. Today, people are sitting with their smartphones, they do various things looking down. We will have a new paradigm shift, because now we will go into the wearable computing era. It means you're more free to move around, be with people. The SenseBoard was a development that started in 2001, but it was not good enough. So therefore we needed some new ideas. It's very important to have the right team, to have people that knows about the applications, that knows about the electronics. I realized that the research that we're doing at our university could solve the problems with the virtual keyboard. With your support of this campaign, we can actually do the technical development and reach an Explorer edition that can be used by application programmers and the first users. There can be apps for gaming, there can be apps for new music instruments. We are mostly interested in making the device for you. So we asked you, people out there, to create new apps that I could never think of. So we'll supply you with an open API. So there's a lot of possibilities to read the sensors, to read the positions of fingers and hands. All of it will be open source. Given this opportunity, it will mean a lot to me. And now I see a possibility to actually make a virtual keyboard with an accuracy close to 100%. And together, we can give the world a new input device for wearable computing.
For those that were not able to see this, what it looks like, it's a C-shaped, like a horseshoe-shaped device that fits over your palm, then sits on top. It kind of, your palm goes into it between the thumb and the index finger. You put one on both hands, and then you basically just type like you normally would. You move your hands and your fingers as you normally would, and it detects the movement of each finger and how fast they move, where they move. It also detects when you move your hands together, like if you were clapping or you were doing something else, or you can swipe with your hand to do enter. Another thing that we've already seen is for people with short-term memory loss or any kind of memory damage, how can we use wearable computers with geolocation, with calendars, with all of the things that are built into them? How can we help people? For instance, if you were wearing Google Glass and you walk up to somebody, it takes a picture of that person, goes through your contact list, figures out who it is, and it displays something on the window of the Google Glass that says, this is Joe. So you won't have to worry about forgetting who people are. On the screen is a picture of an older person who seems to be lost. Another thing that happened is there's a company that makes a shoe insert, like a sole for your shoe, and that sole has a GPS unit in it. So if you have someone that has Alzheimer's, you could put this in their shoes, and if they walk around, they leave the house, you can keep track of where they've gone to help avoid people from getting lost. There's also short-term memory loss. People that have bad short-term memory loss, traumatic brain injuries, there's a project at the VA in Palo Alto, Veterans Affairs, and what they're trying to do is say, let's assume that a soldier comes back with very bad traumatic brain injury. They can't remember what they need to do. So they have a calendar throughout the day. They might say, at 12 o'clock, you need to let the dog out. At 12:15, you need to let the dog in. And at 12:20, you have to feed the dog. So if I have something on my watch, a watch is something that you normally look at. It's a very natural movement. So to put it on the watch makes a lot more sense than to put it on your glasses or to put it on your phone. The other thing is the watch can detect movements and gestures. Let's say that to open the door, you have... So what I was saying with short-term memory loss is that we can actually detect when someone's opening up a door. We can detect when they're opening up food for the dog. And if people are doing this before they have to be reminded, it'll help encourage independence. And you won't have to worry so much about a person having to be notified for every task. So that's one of the things that we're looking at that could be potential for short-term memory loss. Another great thing is for people that have autism or Asperger's, where you can actually have something that detects a person's emotions. So you're looking at someone and you can actually see that they're happy. This is available now. There's a group called Sension, Sension. Now this next one has video, so I'm not going to play the video, but I can describe it pretty easily. Most of you might be aware of VizWiz. VizWiz is an application that you can photograph something and then you share it with a group source, resource, Mechanical Turk, where people will say, oh, what you're looking at is a can of soup, or maybe it's chicken noodle soup. The box you're holding up is cereal. So this group called OpenShades.com, they're working on how you can modify Google Glass to do all sorts of things. Everything they're doing is open source, and they've created an application that is connected with VizWiz and Mechanical Turk. They've also created something called Memento, where you could photograph something with Google Glass, like for instance, a bedroom. And then when someone else takes a picture of that bedroom, instead of going to Mechanical Turk, they'll get what you had photographed and you can describe it ahead of time. So they'll get your picture and they'll get the description you had given to them. And once again, this is open source and it's available now.
Hey, Ted, do you have any slides that you're showing right now? Because we can't see them.
Oh, you're not seeing anything?
No.
Carl, is there a way that you can give me to share? Because it says nothing is being shared. Top version of it. Can you hear me now?
Yes, but we only see your connect window.
Okay, that's good. I can deal with that. Now, can you see it? Okay, great. All right. So this is a project that, oh, are you seeing the right picture?
Yes, sir.
You're seeing the correct screen? This is a project out of University of Georgia Tech where people are able to get instant captioning through their Google Glass. It's a little bit clumsy at this point, But imagine that someone that has hearing disability is wearing Google Glass and they talk to someone and that conversation is instantly converted to captioning. Google also has a patent on speech-to-text conversion as part of the Google Glass patent library. And I'm going to hopefully play this next video. It's because we've talked about a lot of vision and hearing and mobility issues. I think this is a really fascinating one for people that are dyslexic or people that have print disabilities. It's basically a device that sits on your finger, and imagine that you're reading a book and you're using your finger to go through the book. When you use your finger to go through the book, it's actually watching your finger, grabbing the text, and doing text-to-speech.
History of reading. During the next 10 years, many researchers seemed to lose interest in the rewind time and interactive aspects of computer. Instead, most creative energy went into synthesizing realistic images of life and now in real. The mere provision of assistive technology.
This is showing how it works on Kindle as well.
Even if carefully matched and as mentioned above.
So one of the things is, if you couldn't see the video, one of the cool things is that you could be completely blind, and the ring actually gives you feedback when the music cut out or when it stopped talking. What you're hearing, what you were missing was that it gives you feedback, so you move your finger up or down, left and right, so you always know where it's going. This could also be done with something like Google Glass, where it's actually tracking your finger. It doesn't have to be on the finger. So to finish it, I found this quote that says, "The intellect of the wise is like glass. It emits the light of heaven and reflects it." What we're seeing with these assistive technology is that we are expressing our hidden selves with our lamprey-like devices. We're exploring the world with new senses. So if you are blind or deaf, you're now able to experience some of the things from vision or hearing. And we're able to combine reactors and reactions, like looking through the glass and also seeing what's coming back at us. So we can start thinking about how we can solve these issues with assistive technology. For resources, I'm sorry, that this used to be white text, but it went blue when it became a link. My Twitter handle is Ted_Drake, and my website is last-child.com. You can find this presentation and others at slideshare.net/7mary4. Wearability is the project I've been starting with, looking at wearable technology and accessibility. The Twitter for that is wearability.org, and the website is wearability.org. And it looks like I have a typo in that, but wearability.org. So I have maybe just a couple moments for questions. I am looking at the chat room if anybody wants to type it in the chat. But otherwise, I know Carl needs to prepare for the next speaker.
Actually, Ted, I think Jennifer Sutton was asked and had her hand raised in the chat room. Hopefully, Jennifer can type in her question in the chat. So we'll
Okay.
wait a second. In the meantime, I'm going to try a different mic.
One of the cool things you're going to see is that a lot of assistive technology wearable is coming out of universities, and a lot of their work they're doing is open source. So if you're working on a project or you know someone's working on a project, they can actually start integrating much quicker.
You know, possibly because of some of the challenges of Adobe Connect, I'm going to go ahead and enable Jennifer Sutton's microphone and see if she can go ahead and speak out a question.
Okay.
Jennifer, are you there? Jennifer might not have her microphone enabled.
Okay.
Sorry about that. Well, Jennifer, if you have any questions specifically about wearables, probably tweet them to Ted at Ted_. Oh, there it is. Wait a minute. In the Q&A. All right.
Oh.
Cool. All right. So, excellent. Ted, really thank you very much for this really informative session. I really enjoyed it quite a bit. I always like to see sessions on things that are sort of I think of these things as disruptive technology in a way. I love the ideas of being able to have some of these additional wearable technologies, and also I think it's interesting to think about the possible accessibility challenges.
Well, I also think, just to step in just a little bit, I think it's so many of us, we work all day long doing the same thing, like looking at web accessibility or mobile accessibility, or looking at legal or policies, hiring. It's kind of nice, and the reason why I was doing this is to step outside of that and explore completely new things. And I think wearable computing is an opportunity for all of us to get involved in.
Awesome. Thanks a lot. The next session is going to start in 5 minutes. And that one is going to be from Hans Hillen. And so thank you very much, Ted, for your presentation. And
Great. Thank you.
Have a